at point A, the width is equal to 0.05. The depth is 0.01. The Y bar, so we know that this is 20, this is 30, and this is 10 divided by 2, right? So it's 20 plus by 30 plus by 10 divided by 2. Okay, so this will be equal to, it's 0.02 plus by 0.03 plus by 0.01 divided by 2. Okay, so 0.02 plus by 0.03 plus by 0.01 divided by 2 times by 0.01 times by 0.05 is equal to 27.5 times 10 to the power minus 6. Just for simply, or not just to show you, if you look at point A, right, the QZA divided by the thickness at point A, so this is equal to 27.5. Times 10 to the power minus 6 divided by the thickness, which is equal to 0.05, right? So 37.5 power minus 6 divided by 0.05 is equal to 550 times 10 to the power minus 6, right? So this is, if you look at the units, this is in meter squared, okay? Because at the first moment of area is meter cube, the thickness is in meter, is in meter squared. So the next one at point B, right? So point B, so we are going to look at QZ, we're going to look at QZ at point B will be equal to 27.5 times 10 to the power minus 6 plus by twice. Now the width is equal to 0.01, right? And the width, the depth is equal to 0.03, right? And then the Y bar is 20 plus by 15 divided by 2. 30 divided by 2. Okay. So you have 0.015 plus by 0.03 divided by 2. So this will be equal to 27.5 times 10 to the power minus 6 plus, so 0.015 plus by 0.03 divided by 2. Not 0.015, 0.02. Okay. So 0.02 plus by 0.03 divided by 2 times by 0.03 times by 0.01 times by 2 is equal to 21 times 10 to the power minus 6. Okay. So this will be equal to 27.5 plus by 21 is equal to 48.5 times 10 to the power minus 6 meter cube. So therefore at point B, right, the QZ at point B divided by thickness at point B. Right, as you can see, now the second moment or the first moment of area increases, but the thickness now reduced. Okay, so when we formulate this will be equal to 48.5 times 10 to the power minus 6. Then we're going to divide by the thickness. So the thickness is equal to what? The thickness is equal to twice 0.01. This is where we have our T mean. Yes. So 48.5 power minus 6 divided by 2 divided by 0.01 is equal to 2.425 times 10 to the power minus 3 meter squared. And lastly, we are going to look at QZ at point C now. So this will be equal to 48.5 times 10 to the power minus 6 plus by the width, which is 0.05, multiplied by the depth, which is equal to 0.02, and multiplied by the y bar, which is 0.02 divided by 2. So this will be equal to 48.5 times 10 to the power minus 6 plus by 0.05 times by 0.02 times by 0.02 divided by 2 is equal to 10 times 10 to the power minus 6. Let me do it again. 0.05 times by 0.02 times by 0.02 divided by 2 is 10. So this will be equal to 58.5 times 10 to the power minus 6 meters squared. Oh, sorry, meter cube. Okay. As we can see, right, this is where Q max will happen. Right? And whereas at point B, this is where T min will happen. Right? So once you have formulate this, so what we see now is we have QZ. Okay, so therefore at point C, right? So QZ at point C divided by thickness, okay, at point C. So this is equal to 58.5 times 10 to the power minus 6 divided by 0.05. So 58.5 power minus 6 divided by 0.05 is equal to 1.17 times 10 to the power minus 3 meters squared. So this is evident already, right? So remember, what did I say earlier? The higher the Q over T ratio, tau max will increase, right? And why is that? Because the V over T or V over I, okay, V over I ratio is a constant. So from here, right, based on what we have done, okay, this is where tau max will occur. No doubt, it does not has the what? It does not has the highest first moment of area. However, the thickness is what? The thickness is smaller. Okay. So now if we were when we've done something like this, so it comes to your mind, if now, okay, go on, hey, Microsoft, or is it me? So if now, right, if we are now going to like sketch, okay, how this will look, the shear stress. If we're going to sketch how the shear stress will look like, okay. So now I'm going to sketch. So we know that this is at the centroid, right? We know that this is centroid, and some key points, right? When I pick these key points, is because the thickness changes. Can you see that the thickness changes, right? And so these are so-called our limits, right? Our limits. Okay. Then we have another one. And now, if we have an axis that's going up, okay. So this is our shear stress. Oh, no, sorry, this is our y. And then this is our shear stress on the x-axis. And at times, I want you all to have the ability to visualize how the shear stress will look like. Okay. So now the shear stress, okay, at this point, we know will be 0 because the first moment of area is equal to 0. Then it will have a slope looking at a second order negative highest polynomial function. Okay. Then because of the thickness change, right? So down here, the first one, the thickness is equal to what? 0.05. And then the next one, the next boundary, the thickness is equal to 0.02 meters. So what will happen is then you have something like this. And your peak over there. Okay? And then it will come down. The reason why it will come down, right, or get lower, because now the thickness is equal to 0.05. And then you have something like this. Okay. And then if we were to mimic on the other side, you will have this trend looking like this. It will go up like before. Okay. And then it will go down like this. And then it will come down. Okay. So this is how your shear stress distribution look like. So we know that over here is where tau max will occur. Okay. So I don't want to waste time looking for the first moment of area. So I said sorry, not the so the second moment of area is here is IZZ. Okay, so IZZ is equal, so given, okay, in fact you have to calculate, but I don't want to waste time calculating second moment area. It's 4.86 times 10 to the power minus 6. Okay, so given that the question that tau max will be equal to what? Tau max will be equal to 130 times 10 to the power 6 Pascal. And knowing, okay, knowing that tau max will occur at point B, right? So we use at tau max, so it's 130 times 10 to the power 6. So what we want to find is we want to find what is our Vy or our Vmax over here. Okay. And then this will be equal to 4.86 times 10 to the power minus 6, right? And then we are going to use the Q over T ratio, which is equal to what? 2.425. Okay, so 2.425 times 10 to the power of minus 3. Okay. So from here, Vmax will be equal to 130 power 6 times 4.86 power minus 6 divided by 2.425 power minus 3 is equal to 260.536 times 10 to the power 3. Okay. So just to quickly summarize, okay, so the lecture today, we focus on what? The Q over T ratio. Okay. And this is the first, or not the first time we have done this before. We have started to do what? We have started to do comparative analysis. Okay, this is important. Okay, and why this is important, then you can counter, okay, you can ignore point A. Point A will not be the maximum, but point B and point C might be the maximum. Okay, that's all I have for today. Now, next week on Thursday, okay, I will not be teaching, but you all have questions regarding term test 2, regarding the topics, okay, I will like do a revision, or you just tell me, Eugene, can you do homework 3, question 2, or whatever, I will do it. Are we clear? If you all have no question, have a great, fantastic weekend.